Hello, everyone. I'm Alicia Swami. I'm here with my co-hosts, Keely Severson and Eric Johnson. We are exposing mold. Today, we have Gianni Rossini. He's the founder of EnviroBiomics. Is that how you say it? Is it
Yep.
EnviroBiomics?
Yeah, you got it.
EnviroBiomics. And they are a leading commercial environmental lab in the USA that specializes in analyzing samples to determine the presence of mold, bacteria, and other microorganisms, including the ERMI, the hurts me too, actino, mycotoxins, and endotoxins, etc. EnviroBiomics collaborates with environmental and medical experts who make crucial decisions about the indoor environment that have an impact on the health of our communities. They employ research and innovation to produce reliable data that people can rely on and develop over time with resource saving solutions. Sorry about that. Welcome, Gianni. Thank you so much for joining us for a second time. It's a pleasure to finally see you. Last time we were only able to hear you.
Yeah, my pleasure. Happy to be here.
Yeah. So, we work with the mold community, and we know the ERMI test is extremely popular. Could you maybe explain more about just the company that you founded and just sort of the history, and we'll see where we go from there.
Okay, great. Well, I got involved in this area about 10 years ago when I was with a large engineering environmental company here in San Antonio, Texas. We did studies. I was there as a senior research scientist with a group of people there doing the studies, and we got involved in ERMI. My contribution was ERMI, endotoxin, and allergen, mycotoxin for studies that related to the children's health. And after that, I kind of jumped into consulting. The study got cut short. It was very expensive. It was $1 billion study for the U.S. government. And after a number of years, it got cut short, and so I decided to do something else. At that point, I knew some people in the EPA, like Vesper, which Steve Vesper was Richard Hagland and Tina Riponin. There are three people that they published the original work on ERMI, and they were like my mentors during the time I was involved on the government project. So with the help of Steve Vesper, I decided to, they say, hey, why don't you go to set up this ERMI testing in other countries like Australia and Hong Kong and other places. And first I went to Australia and got involved with the David Lark. David Lark is an environmental professional that he ran a lab over there in Australia. And so he wanted to see the ERMI over there. And I guess we were one of the first one to run ERMI in Australia and validate that and publish that with the Steve Vesper. So after that, I say, hey, why don't we go back to San Antonio? We open a lab so we can do this here in San Antonio. And more important, let's develop this other thing. It's called actinomycetes, actinobacteria testing. So that's pretty much a short story of 10 years involvement with this ERMI and related stuff.
Wonderful. So for those who are listening, ERMI essentially just means Environmental Relative Moldiness Index, and it's a research tool that you guys had developed to estimate mold contamination in homes. And it's something that a lot of people go to just get some information. I mean, I've used ERMI probably 4 or 5 times. I know so many other people that have used it a lot. So it is definitely a beneficial tool. And just with the progression of your company, are you seeing more and more people just ordering this test and getting information? Like, has there been a major growth spurt in what you're seeing kind of in the industry?
Well, I don't know. what's the best answer to that? We have a piece of the market. There's other companies doing this, and we try to do it the best. ERMI in town or anywhere. The ERMI itself is a basically is a PCR. PCR is like you do a COVID-19 testing, but instead of doing one target, we do 36 target, and then from there we calculate a ERMI score. The number of tests we run is growing year to year. And, I'm sure people find it useful, and that's why there are more people interested in running ERMI versus other options, which are a number of options to do mold assessment, which some are more expensive than others. And but also there is a cost benefit relation between, ERMI give you 36 species at the species level, a very quantitative method. And obviously there is other method that the microscopy, the traditional method that you use all the time, that are very valid, that can be like an air trap, and they're used all the time. I think they're used in conjunction. I mean, they're together. They don't have to fight to each other for the same. So yeah, there is a growing interest in running ERMI because at the end of the day, you need to have it is a very valid, very precise measurement of what's in your environment. Obviously, it's not the same like an air sample. Air samples, you can also run ERMI in air samples, but there are different uses. People use it in a different ways. There's a number of professional people that collect samples. They like to use it in different ways.
Awesome. Yeah, it seems like it's just a more expanded mode of data collection to do the ERMI and then do like an air sample testing. And so you guys are just doing the surface level
Right,
sampling and then sending it through the PCR. In terms
right.
of your species list, has that grown since you started? Like, what was the determination between you and your team of, okay, these are the molds that are harmful, these are the molds that are common? Like, can you talk a little bit more about the species
Well,
you guys chosen to PCR?
well, the original list was selected by the EPA. The paper, published by Steve Vesper and others. Um, the 36 selected species. Basically, what they did is they screened water damaged homes, and they found that elevated species, and then they found all species that don't change with water damage. So they selected 30, no, 26 that elevated with water damage. And they, like a reference, they use 10 species that don't change with water damage. So the ERMI, you have two groups. Group one is 26 species that are water damage related. But to get to that number, they screen, I don't know, 100 species. And they did PCR on, I don't know, icing paper with more than 100 mold species. And a lot of them don't change. Some of the ones that change, significant change with water damage, they're selected. And that's why they're being used in the ERMI, group one. Group two is like, it's a normalizer, it's a control. It's a way to make sure that the test is running well, and it gives you some information. And from there, you calculate a score. Obviously, the score sometimes can be misleading, but in general, the score correlates very well with what's going on in the environment. When it's misleading is because the sample was taken in a way that is not recommended. For example, you take a targeted sample, you go to the source, and obviously you're going to find a lot of whatever you're looking at. It's not very useful. You're already looking at the mold in the wall growing. So, but if you follow the instruction, you take from different rooms one regular a home, let's say it's regular home size, you take one ERMI, it give you a good indication if the environment was through water damage or is at the moment water damage, because it's data that you collecting is not just a picture of the moment. It's a historical picture. It's actually take dust, whatever dust you have from day one from the house, whatever is there. So what it mean is not, it's like if you take an air sample, whatever is in the air, you are measuring the air, but what's in the floor, you're collecting day after day after day dust. And so the ERMI is measuring what's in the floor, in the actually dust that's being deposited into the furnitures and into the surface. And that can be this year, depending how many times people clean.
Yeah, I always wondered because the ERMI, it's not like a set, like you don't have one ERMI for each room. Like you get an ERMI. I mean, you could if you
Right.
wanted to, but you take
Yeah.
an ERMI and it's kind of sampling all these different areas. So it's really hard to find source points with an ERMI. It's more so, like you said, to show like a snapshot of what's going on in the home, correct?
Yeah, that's correct. And that's because of the price. It's $240 each, and you're not gonna do 10 in the whole house. You spend $2,000. And if you do a RMI for a whole house, just don't go into the basement, don't go into weird place like a crawl space. Just stay in the regular areas where you normally use. Then you get a good idea what your exposure is in terms of mold. Yeah, pretty much that's a way how you use it. If you have a building, you want to go into basement, yeah, of course, you have a different sample. Don't collect samples from the house and the basement together. Or if you have a source like you're looking at, don't go to the crawl space. Crawl space tend to be very dirty, and you don't really normally go into the crawl space. Don't take a sample from there. So you normally take a sample from wherever you occupy during normal, activities of the building. It give you some people collect 2 or 3 samples, remediation people, professional that want to know a source. So they kind of get an idea that first level, second level, or basement. And so they know where they're coming from. They're coming from the basement most of the time, where the water damage is, or maybe coming from another place. But they want to get this 3 sample kind of thing. But there's nothing wrong with doing 1 sample. If you want to save money and you want to just get an idea of your area, and if it's normal, then you don't need to go and find mold because it's your living quarters areas are normal.
I
Now,
think
now you do an air trap, you can do an air trap, but of course you're going to save money. But there's also more to it. It's going to be most of the time, 50% of the time, it's going to be negative. And if you do negative, doesn't mean it's safe for you. So at that point, it depends on your reactivity. If you are very affected by mold, then you're going to need an ERMI. Air trap is not going to be enough.
Thank you for making that distinction. I was just going to say, I'm not sure if I agree with you, Gianni. If the the test
Yeah.
comes out negative, there could still be a problem. So I do appreciate you being forthright with that, because we do see, depending on collection methods or just
Right.
the standard limitations of testing in general, could yield false positive. So in regards to the 26 water damaged species, which ones would you say are the most dangerous?
Well, the black mold, stachybotrys, usually one of the top of the list. There's a number. All of them are bad, but I guess a black mold is always look into like a special case. Um, uh, we have ketonium also. globosum. All of this stuff are, the one that you find in HERSMI 2 also very important. HERSMI 2, they're clinically important for doctors that want to look into the impact of mold in people's health. So I would say that some people like to do follow up with the HERSMI 2 test because they're only 5, they're less expensive, and they can do more testing that way. But yeah, the stachybotrys, the Catonium, and are probably the top of the list.
No, that's really fascinating because Dr. Shoemaker, as a result of his gene transcriptomic testing, says that mycotoxins turned out to be less than 7% of the gene activations in CIRS, chronic inflammatory response syndrome, and he's completely switched over to focusing on actinomycetes, to the point that he even criticized me for my obsession with Stachybotrys.
Yeah, well, I don't know. I know about Dr. Shoemaker and his switch into actinobacteria. I guess they did a clinical testing with Genie, and they found that a lot of what they're looking into the genetic testing is they're seeing the impact of actinobacteria, like a 40% impact on their test. But I think mold is about 10%, I think, and another 10% for
Well, he started
endotoxin.
out by saying 7%, and that number seems to keep getting smaller and smaller until he was literally apologizing for naming his books Mold Warriors and Surviving Mold.
Right. Yeah. No, I say 10%, but yeah, 7% maybe is the new number. Okay. I actually asked him about it, how you calculate this and all that. It's all clinical correlation between the test and what they see in the clinic. And I cannot speak for his change of mind. Mold are still a good indicator of what's going on in the house. And clinical indicator, I don't know. I think mycotoxins are always been very important, not only in the food industry and also in home safety, and WHO is very clear about that. So we know a lot about mold. Actinobacteria is something new, and even well, what he's looking into is looking at a correlation between a test that is done in blood with the clinical symptoms. And his view is 40% for something and 7% for mold. I don't know what to say about that. We are not setting in this percentage here in this lab. This is tested somewhere else. It's Genie is done by another lab and they're working with Dr. Shoemaker.
Yeah, he's currently working on a dominance index of the pathogenic actinomycetes species that he considers to be the most important. And there again, it's similar to the tests done in the past where they take the prevalent species that they find where people are getting sick and try to extrapolate from that which are the worst ones and the ones most likely to be the offenders in this chronic inflammatory response syndrome.
Right. Yeah. Well, I think this I don't know, if you look at this from another perspective, mycotoxins are bad, and those are produced by mold. So water damage building and all that, it's a very clear picture right there. Now let me tell you, mycotoxin, the mold, mold used to be found that produce antibiotics, right? Antibiotics are never been bad, but some of them are bad. Yeah. I mention this because actinobacteria also produce antibiotics, and some of the stuff they produce are bad. They're toxin. They're kind of they're known as ribotoxins. Ribotoxins are toxins that affect protein synthesis. Now, I think the group Shoemaker and Associate found a lot of ribotoxins are found in the in the clinic. They find that there's a lot of inhibition of the ribosome. There is also a lot of problem with the mitochondria. Well, I can tell you the same thing happened with the mycotoxins. So I cannot separate between the two, between toxin produced by actinobacteria or mold. I don't know how you can separate those two things. If you put together and say, hey, you have a bunch of toxins from mold. Yeah, those are bad, and they inhibit the ribosome. Then you have a bunch of toxins from bacteria, actinobacteria. They also inhibit the ribosome. So which one it is? Maybe both. I don't know how you separate that.
Yeah, and it's a curious thing that actinomycetes are known as are very powerful producers of various compounds that are useful, like antibiotics, and they've been extensively studied since the early 1900s.
Yep.
So
Yep.
how could a pathogenic quality have been completely overlooked for all this time?
Well, it's not pathogenic, it's toxin, okay? Pathogenic, something that grows on you. And toxins is like a chemical that produced by this bacteria. Sorry about that. So it's overlooked. Well, if you look at there's a number of compounds produced by actinobacteria. There's like thousands of compounds. A lot of those compounds inhibit the ribosomes. Some of them are very potent. And the same thing can be said by mycotoxins. Mycotoxins also inhibit the ribosomes. So they have overlap. They overlap in several ways. I don't know how you separate the two. That's my view on it. I would say that, yeah, you can say, well, antibiotics are produced by actinobacteria. Yeah, sure, I agree. But you have mold that actually penicillin was the first antibiotics that we ever known. So we know antibiotics, it can be a misleading kind of guiding thing. This stuff, bacteria and mold produce toxins. And they do similar things. My only point is like, how do you separate which one it is? I don't know.
Yeah, I mean, they can't be separated. Dr. Shoemaker and Jimmy Ryan are claiming that these ribotoxins interfere with what they call the sarsen-ricin loop, which a fundamental process that exists in every living organism.
Right.
So if that's true, then the whole idea of a genetic component goes out the window, because here we're talking about ribotoxins, which affect all living things.
Well, you still have a genetic component because this genetic thing, the HLAs, are important for presenting this stuff, and all the cells have this in the surface, and they process this like this is something that they don't recognize normally, and it's a way to prime the cells on that there's something going on and presenting this stuff. That's the HLA. And the ribosome and the sarsen loop is everywhere, but the sarsen loop is in bacteria, is in everything. But the way you have to look at this, there's a chemical warfare between mold, bacteria, and we are in between. This stuff are producing toxin to attack to each other, and kill each other. And it happened that we are right there, and we're not supposed to be there. And that our cells, they have this sarsen loop thing that bacteria producing this potent antibiotics that attack in that region. And but there's some of these compounds are toxic to us, very toxic, like ricin and sarsen. They're used to very toxic stuff. And So, and they're found in mold. Aspergillus produce some of this sarsen, which is a toxic stuff, but also bacteria. Actinobacteria produce hundreds of thousands of compounds, a lot of medical use, anti-cancer, antibiotics, all that, but they also have a number of compounds. They are similar to mycotoxin, doing the similar things. So I would say we cannot overlook at the possibility that bacteria, actinobacteria especially, are a source of toxins for us. And they're attacking in a similar way that mycotoxins are attacking us and affecting our, ribosome and mitochondria, all that. I don't know how you separate one or the other. That's at the end of the day. That's what I'm thinking. Now you can measure mycotoxin in dust samples. You find a bunch of them, but you can measure toxins from bacteria also. Right? And there are people doing this right now, and they're developing method to follow actinobacteria toxins. It happened that it's new, and and it was not regulated like mycotoxins are regulated right now. It's a huge regulation everywhere for food, but also for home. Now we see a lot of people are testing for mycotoxin in their, in the urine, or testing in their homes and all that. I think eventually something similar is going to happen with the toxin from bacteria.
Yeah, it's notable that Joseph Forgax, who's literally the father of mold investigation in the United States, called for further research into toxic mold back in 1960, and made the observation that he was seeing actinomycetes in conjunction with cases of autism. But he also reported a strong lacquer-like odor that was difficult to overlook.
The lack of what?
Lacquer. It smelled like lacquer very powerfully from
Okay.
actinomycetes.
So they found autism relation with mycotoxins,
Not with mycotoxins, with actinobacteria.
with actinobacteria.
Yeah,
Okay.
yeah,
And in the 60s.
yes. And he put
Well,
out a paper that's in the bioaerosols manual
there you
asking for
go.
research into this.
Right. There you go. There you go. I think there is a lot there. There is a huge amount of compounds from actinobacteria. Those compounds are doing something. And I know a number of compounds. They're attacking the ribosomes, same like mycotoxins. So there is overlap. And my guess there, when you have bacteria mold growing, bacteria is going to grow pretty soon. Water levels for bacteria growing is like 0.9 or something, very high. But many times when mold is growing, bacteria is going to be there, and the bacteria is doing something. And actinobacteria seems to be a good, reasonable thing. Now, the details of how Dr. Shoemaker found this relation between actinobacteria and their marker, they use the Gini marker. I don't know all the details. I know there's a good correlation. That's all I know from there.
Yeah, the curious thing about ribotoxins is they affect the cells at such a fundamental level as a dysregulator of protein synthesis that they don't necessarily exhibit a cytotoxic effect that immunologists would be looking for. So they could go completely overlooked.
It's it's the protein synthesis of the ribosomes, and then that is have a direct impact in the mitochondrial energy production. So there is also a reaction right there that the immune response get activated. Somehow there is it's all connected. That is person is responding like, hey, we are under attack. Let's start fighting this stuff. And you know, this ribosome connection with the mycotoxins and the bacteria are, I think it's a fundamental connection that if you have, you're only looking at mold, you're not looking at the whole picture. So I think bacteria is an important component of the toxicity in people's homes. Actually, if you measure bacteria, you have millions of bacteria. If you measure mold, you have a couple of thousand of mold, 10,000 mold. And the toxicity or whatever their things are doing, they're doing, chemicals that are affecting our ribosomes, and the level of amount they're producing, they're similar. So you have millions, they're going to have more toxins with bacteria than mold. That's a good guess, Now, which one are the toxins? I don't know.
I was trying to introduce Dr. Shoemaker's work to Stanford, particularly the Open Medicine Foundation, which is studying ME/CFS, myalgic encephalomyelitis chronic fatigue syndrome. And I'm having a bit of difficulty here because they say, if any of this were true, you wouldn't be the only one here. So is there any possible way to get researchers to maybe assist in going to Stanford and trying to get their attention on this issue?
Well, that's, I think it's a job for Dr. Shoemaker to go over there and then convince them. I think he has all the research, and we collaborate into that, but he will be the only one. And Jimmy Ryan, he worked with him, that says, hey, this is what's going on here, and let's look into this. I don't know specific toxins, and now he has an index, and the index is looking at a number of actinobacteria. Where do you go from there? And we also do something called actinoskin, which is tested on the skin and back of in the back of the earlobe. There is correlations with Parkinson, Alzheimer, all the stuff. They produce bad stuff, and it's been published. Propionobacteria acne, very common. When we have 10 millions in your skin, then there's something going on. Now, everybody knows that. It's very well published. Everybody that looking into the literature. Well, why the Stanford is not looking into that? Propionobacteria is a actinobacteria growing in your skin on the millions. Why? And they're producing Parkinson, publishing, I don't know, 10, 20 different peer-reviewed journals. Why nobody's looking at that one? It's just one, but hey, you have it right there.
Yeah, I remember British researchers found spinal degeneration that had Propionibacterium acnes growing all over it. And this was thought to be a skin bacteria. So
Right.
It was very unexpected to find it in the spine.
Right, in the spine. Okay. Well, this stuff go into your skin, and it's not just in the surface. It going deep into the skin, and then produce little vesicles. They're called exosomes. They're little fraction of bacteria, little bubbles of bacteria. They're nano sized, and they go into your blood, and that's where we measure this stuff. Actually, we do exosome in blood, and we find a lot of bacteria there, propionobacteria. Where is coming from? Well, it's assumed from exposure to the environment, or somehow this individual is propensity to grow this stuff in their skin. They don't have the same immune defense as everybody. Either way, there is a good correlation between propionobacteria and a number of degenerative disease like Parkinson, for example. There are a number of publications, and people are looking very close. And this is an example only of actinobacteria.
Yeah, it's fascinating that one of the Open Medicine Foundation's leading researchers, Professor Maureen Hansen of Cornell, has been focusing on exosomes and is finding it in the blood, but so far unable to identify them.
Oh, he was unable to find exosome in blood.
Yes.
Well, you can send him to us. We could do it every day. We do
Excellent.
it. Exosome in blood is very well. It's you know, you can go on Google search and you have a kit for exosome in blood, and everybody sell one kit for exosome in blood. Now, gonna find bacteria there? I don't know. We find bacteria there, and we sequence this every day. Well, not every day, every week, because we do it once a week.
Well, that's it.
So
I'm going to
now,
Stanford and refer them to you.
right, tell him to come over here. We see bacteria there, and now bacteria in blood. We look at propionobacteria, and we do only corynebacteria, only actinobacteria. We're looking into blood, and also depend on the levels. We're not just looking at one or two. We're looking at a big number of bacteria in exosome. DNA, we're looking, not bacteria. We're looking DNA in exosomes. Yeah.
Yeah, I think the problem is they just don't have access to the methods which are actively correlating the PCR testing with various species. So they know something is there, but as of yet, last I heard, they've still been unable to make a positive identification.
On blood, you're talking about?
That's right.
Right. I think that there is a little bit of controversial topic, and it's still on in early. Some people agree, some people don't agree. There is some people in the UK that publishing all the time. Some people says, well, that's a contamination. That's something that coming from some other place. There is a, I don't know, last time I checked, it was like a study with 10,000 individual and they did blood, next gen sequencing in blood, and they found bacteria, but there was no correlation with gene normal and not abnormal. It was like there was no pattern of actinobacteria or anything like that. But yeah, there was bacteria in blood, DNA in blood, DNA. Now, the correlation between DNA in blood and this disease, that's another step that, I'm not jumping into that. I'm not proposing that. I'm saying this is coming from the Dr. Shoemaker. Yeah.
Well, it's certainly very interesting and needs to be followed up on.
Yeah. Yeah. It is. I think that thing, what I want to leave like clear that bacteria, actinobacteria, they produce a number of toxins similar to the mycotoxins from mold. And I think they cannot be overlooked. Only time will tell how important are those for human health. But my guess they are important.
I'm just disappointed in Dr. Shoemaker's shift in focus because Stachybotrys was a very good bit of leverage to get researchers to listen to us.
Right. Yeah, no, I agree 100% with that. The thing is that we do mycotoxin testing here, and we do LC-MS, which is it's at the state of the art. There's nothing better than that. It's not an ELISA test. This is it's a very expensive machine, and it needs very expertise. The thing is that we don't find a lot of Stachybotrys toxins. We don't see that. And where are the toxins? That's the thing. If I look at the toxin that we see, we see a number of toxins, mycotoxins, but not a lot. Not ochratoxins. We've done, I don't know, 700 tests in a year, and I don't never see ochratoxin there. Some people do. Some people do. I don't know what's the difference between us and some people do.
But it seems that if some of these toxins are on the nanoscale, they could conceivably penetrate the olfactory nerve, stimulate the microglia directly, and bypass having to go through the immune system.
Right. Yeah. If you're growing this stuff or you go into the air and they go directly to your blood, then from there go into different target organs. Normally not eliminated very well in the urine. At least that's what I've been told, that uh, this stuff tend to accumulate in target organ. They're very lipophilic. So but people are doing urine tests and they're finding all this ochratoxin, all that stuff in blood, in the urine. Now they're doing it by ELISA, which is not a valid method. It's not FDA approved method. But yeah, it's a valid general, it's a good method. It's nothing wrong with. And they're finding a lot of toxins in urine and also in the dust of their homes. It's ochratoxin positive. I've never seen ochratoxin positive. I don't know why is the difference. And I talked to the expert. I talked to people in the European countries that I know, and they tell me, well, they don't know. They normally they don't see it in the dust either over there. I don't know who is right, who is wrong, but I know companies in the U.S. doing very good techniques like LCMS, MS. They're finding, I believe they're finding ochratoxins or other stuff in their dust samples. I'm not finding that stuff. I don't know why. It could be a technical issue, could be something. Now, why we mention this? Because toxins are produced, mycotoxin produced by molds is the big problem. But I don't find a lot of mycotoxins. That's a good thing to know. Where are the mycotoxins? We find something, but ochratoxin never, and gliotoxin never. And we do like LCMSMS, which is like state of the art, doesn't get any better.
I'm not really familiar with LCMS or what you're referring to. Can you just talk about that?
Yeah, it's a it's a mass spectrometry.
Oh, okay.
What it is not a ELISA. ELISA is an antibody. It's an antibody reaction that normally done by some labs. They do a urine test with antibody, ELISA. But when you do a MS, which is liquid chromatography mass spectrometry, which go in tandem, tandem means twice. So what you are actually looking at is the actual molecule, the mass of the molecule. Let's say it's 500, let's say 500 Dalton. You're actually looking at a peak in the chromatogram. You're looking at a mass of 500, for example. And next to it, you have a spike of radiocarbon label ochratoxin, and you see the peak of the ochratoxin next to it because it's carbon 14. And your ochratoxin is peak is next to your target, target and control next to each other. You're actually looking at the actual molecule, the chemical molecule, and that's called mass spectrometry. And these are very precise machines that are very expensive and need a lot of expertise and need a standard. The standard is a carbon label standard. It's not easy to get. And they're produced by European countries, most of the standards, actually. And maybe some of the standards are hard to get. And the people are using standards here in the US that are not that validated, that they're using different standards over European countries. But let me tell you, there is June, there is a mycotoxin conference here in Gordon. It's called Gordon Conference. And have some European friends coming to talk about mycotoxins and picotoxins. And they're presenting their data. And we're sharing some of the data with them on mycotoxins. So the data is that, hey, we don't see ochratoxin, we don't see gliotoxins on the sample in the US in general. Is that a technical problem? I don't know what it is.
Are
Oh,
you
yeah.
are you referring to the DR talks with Dr. Eric Gordon?
Yeah. No, the Gordon Conference. Sorry, it's the Gordon Conference.
Oh, okay, yeah.
It's a
Because
very, very like they do like 1,000 different conference there, Gordon Conference.
yeah, I just saw the advertisement for that one, and this one is directed specifically in the title to
Right.
chronic fatigue syndrome.
Okay. Well, it could be the same one. I just got an email from my colleagues and they say they're gonna be there in the conference. They want some data from me. They want to
Yeah, and
know.
I've been actually trying to pressure Dr. Gordon and the speakers of this conference to reveal that toxic mold actually started chronic fatigue syndrome, which as of yet they have not done.
Right. Yeah. I agree. There is a lot of stuff there that is is not very popular. Maybe that is they don't want to release it like hey, we this is our chronic fatigue. There's done I don't know how much money is spent on chronic fatigue and never find something to explain chronic fatigue when easy to explain with mycotoxin and mold. You know, that's right there in your face.
Yeah,
And
it's not only easy to explain, but it was documented in the
it's
original chronic
documented.
fatigue syndrome cluster. And this has
Right.
been known for 35 years.
I know. Yeah, it's right there. It's very, very familiar to you and me and a lot of people that are in the field of mold and mycotoxins. And why the government is not paying attention to that, I don't know. So,
Well, I'm going to stick Alicia on him. She'll nail him good.
right.
We always attend these conferences, and I don't know if you were present for the recent White House. It was like an indoor air quality summit that they had, and it was 3 hours of people talking about the indoor air quality, and of course, they posted around COVID, and it was just so interesting that it's like they can go 3 hours without mentioning mold.
Okay.
Even though mold is a very serious
Right. Yeah.
problem for the indoor
Right.
air quality. And so you would think that
Yeah.
you would at least make one mention of like,
Right.
this is what we have to do, and this is what we can do. This is the testing,
Right.
all that. But no, they were very elusive and they focused more on gas stoves being a major issue
Right. Gas
for
stove.
air
Yeah.
quality. So it was just kind of weird. I wanted to share that
It
with
is. I think it's because a lot of it, maybe the professional background is engineering or some other kind of background, and they want to keep it on the same area. I mean, engineers they're always gonna go with the with their preferred, you know, area of interest, air samples, and all that. I know some engineers that are interested in mold, and but I guess a doctor, medical doctor, is going to find a problem that is normally he went to school for. If you go to an architect, he's going to find a problem with the house. So everybody find their own problem because that's what they know. But mold is in the WHO have a lot of warning about mold and recent warning. The mold is a big problem. So, and we know that not just because WHO, we know that because it's a regulated, mycotoxins are regulated. It's a big industry that's regulated because we get poison. Toxins on mycotoxins are highly regulated and they're tested everywhere. So all the food that we consume, but food is not the only source. We are water damage is another big source. So we need to worry about water damage and the food. But food is something the government take care. You take care about your home, your water damage. So, and the main culprit on the water damage are mold. And nobody can deny that. And I think just you had to go against the international, like the WHO and other organizations, if you want to deny that. So I I think that we are in the right track. And obviously there might be other stuff there that we want to take care. It could be actinobacteria. I don't know. There is something that we have to wait and see.
Do you think our food source is a significant source of mycotoxin contamination?
Only if you let it grow and just then you're in trouble. People that are all age, they don't have a good eyesight or something. You can grow food and eat it. And if you
Like
don't
if
have
the food in your house goes moldy,
no.
you're saying? Is
Yeah,
that what
yeah,
you're
yeah,
saying?
yeah. Only if it's going moldy. Otherwise, if you buy fresh and you consume without mold, you're fine. You should not worry about it. The government worry about it. They test your food. They measure mycotoxin in the food. That's highly regulated.
Right.
So food source is not a main problem. Only if you leave it there and then start growing fusarium and other stuff, and they start flying like a mold fly everywhere. And then all of a sudden you get water damage and then start growing mold in your house. But more important, Stachybotrys that's hiding behind the walls, behind the floor, on laminated floors and stuff that you remove the laminated floor, you get a lot of mold growing there. Those are the kind of thing that we need to worry about, not the food, really. Because food is, I think, the government need to worry about that.
The
Hopefully.
main way we uncovered Stachybotrys is in the early days before there was any testing. People simply led researchers, doctors, to the areas that were bothering them, took
Oh
samples,
yeah,
and that's
yeah,
what
yeah,
showed
yeah.
up.
Yeah. Show up areas. People are reactive to this stuff, and they can tell this is the place, and they look at it and they find it. And I was listening to one of your presentations right there. The Jeff Charlton finding the stuff in outside the house. Actually, I know Jeff very well, and I'll talk to him about next time. But yeah, and if you find it, it's a source of concern, and you should remove it. But keep in mind, not always producing mycotoxins. Some of the stuff that if they don't feel, mold are like animals. They're attacking to each other. If they feel they're happy in your house, they're not going to produce mycotoxins. But be better safe than sorry. So better take care of it, get rid of it. And it's not the visible mold that you worry about. You worry about the one that is detected by ERMI or air, the sport trap. That's the one you worry. The visible mold you can go and paint over and get rid of it somehow. Yeah.
Thank you for that distinction. I wanted to ask you, so you have this testing method of mass spectrometry, or I don't know if I said it right.
Yeah.
I'm so
Yeah. You
bad at
got it.
pronouncing things. Did I say that right?
Sure.
Mass
Yeah.
spectrometer. There you
Yeah.
go. And so you're able to see the mere molecules. So do you guys do any bulk sampling? Like if I were to send you a contaminated shirt, would you be able to run that through your test and analyze it?
I don't know. I don't know because we do extraction from the dust. So we put acetone into the dust and acetone and water, and we get the mycotoxins out of it. I don't feel like putting the whole pans or I don't know towel inside of a big acetone tank and get an extraction. I guess you can put a piece of it, yeah, but yeah, you can test anything, I guess, unless acetone will destroy the actual fabric. I don't know. Normally, we'll stay away from. We do all kinds of samples sometimes. If, for example, for doing ERMI, you have piece of paper. You're gonna mess up the paper because it's a water salt. It's a water soap and water. Basically, you put into the Swiffer, and then you do extraction of the spores. Let's say if you do it with paper or a filter on the wall, a filter. If the filter go into solution, then you end up with a lot of paper in the bottom, and that will be a problem. So acetone is a problem for maybe some textiles, It will get the color, it will maybe interfere. I would think stay away from testing actual fabrics and stuff. But people test food. So food, all kind of food, cereals and all kind of food. So I'm not surprised that you can test anything really after you're testing all kind of food.
Well, if you're ever open to it, we'd love to do some mad
Right.
science experiments with you and send you pieces of contaminated clothing just to see if you can see the
Right.
molecules in it. Or I'm, I'm
Well,
just throwing stuff out there.
we test dust all the time, and 10 milligram of dust that you collect from your home, and we find very few mycotoxins. We find, you know, if you see 100 samples, we never see ochratoxins, we never see gliotoxins. I explained that other labs, they do see this. I don't know if the method is a difference, or, whatever. But I wouldn't worry about actually your clothes or your fabric or whatever you're using. I will go into the dust right away. If it's not in the dust, it's not going to be in your clothes. Unless somebody's, I don't know, using moldy stuff and growing in your clothes. Yeah, why not? It's right there. I will throw away that because it starts smelling or something. Better get rid of it.
Do you think the mycotoxin found in the dust is a good reflection of what's inhaled in the air, or do you
Well,
think
that's
it's
a good
possible?
question. That's a good question. It's a very good question. It's not. It's not. In the air is what you go inside your nose, and dust in the floor is in the floor, right? Yeah. Well, sure, but in the dust, it's a good proxy to what's in the air because the dust will fly eventually. So you don't want to measure the air because the detection is very difficult. You're going to be negative, like an air trap. You're going to tell, oh, my air is good, but the floor is very contaminated with mycotoxin or whatever you're testing for. It's a good
No,
proxy. Yeah,
I'm
it's a way to test and tell you, hey, there's something going on here. If you test the air and open the door and let the window fly the air, fresh air, your test is going to be negative 100% of the time, but your floor is going to be contaminated. So that's the difference. So you had to focus on whatever is more sensitive, and you had to focus. Obviously, you're not breathing the, stuff in the floor, but eventually, you open the door, the stuff is gonna fly, and it's gonna end up in your nose. So that's the point.
Yeah. Or if you vacuum or whatever.
Right.
Yeah.
That's the
I
point,
think
and
I
it's a
think
good
maybe I
proxy.
wasn't clear in my question. I'm trying to ask if you think that there is also mycotoxin in the air that could be higher qualities than what's in the dust, but it's not found because we're checking in the dust and we can't really
It's a
process
different,
samples in the air.
like the air is different kind of mycotoxins than the floor. Is that the question?
Sorry, my baby's crying so loud I don't want to unmute myself. No, it's more of the question is more about the concentration presence of mycotoxin maybe not being best detected by dust is what I'm trying to ask you. Like, is it possible that there's much more mycotoxin in the air that's being inhaled, but because we're only checking in the dust, we're not really finding what's in the
Right.
air?
Yeah. I think the other way around. I think that there's more in the dust that is in the air. I will find very difficult to believe there is more in the air. That's why we don't find ochratoxins or gliotoxins, because we're looking in the wrong place. But well, I don't know. People are detecting this stuff mostly in their, I don't know, human samples, maybe urine samples. But we don't see it in the dust. We don't see it. And that's what it is. We see toxins, yeah, we see, but we don't see ochratoxin or gliotoxins. That's very, very rare. We see other stuff. Now, are you going to find more in the air than in the settled dust? I found very difficult because settled dust, it's concentrated. It's concentrated in the sample, and it will accumulate whatever is in the air. If you let it settle, it will go down to the floor. So it's better to collect from the floor. For not the floor, I'm talking about from the surface, not the floor where you're stepping on, but talking about surface. So any sample is better, more enriched in dust that is settled dust. Yeah. Air sample will always be more diluted, and it will mostly going to be negative. In my view, we don't do air samples, but if we do air samples like ERMI air samples, we'll see very little ERMI in the air samples. And some people do that. And we do it with air trap. You know, they send us an air trap, we do ERMI on the air trap. That's fine, we do it, but it's a fraction of what we see in the settled dust. The same is true for mycotoxin. That's my opinion. Yeah.
Thank you for answering that.
Sure.
Well, thank you so much, Gianni. It was wonderful to have you on today. This conversation was awesome, and I do appreciate your time. Now, if anyone wanted to go ahead and purchase an ERMI or any other test from your company, where can they find you?
EnviroBiomics.com. That's the best way to find us. Actually, I don't even know the phone number here, but we get called. I mean, I guess everybody find us in the website. That's the easy way. And you can use your cell phone or your computer, anything, tablet. EnviroBiomics.com, the place to go.
Fantastic. Thank you, everyone, for joining us today. We'll see you next time.
Okay, thank you.